Hey guys, so I figured I'd show a little bit of the CAN bus reverse engineering that I'm doing. So right now I've got the race capture hooked up and it's looking at two different bits of information. On the left it's looking at a CAN bus message ID of 896 and the data byte is in position 1. And then on the right it's looking at the intake air temp from OBD. So it's an OBD PID standard unit that's already converted. So right now it's saying that intake air temp sensor is measuring 54 degrees Celsius, and I just have some arbitrary value that I don't know what it is yet on 896, message ID 896 in position 1. And I think, just based on some logs that I've done already, that 896 address in position 1 corresponds to intake air temp. So I'm going to take some compressed air and blow on the air temp sensor to cool it down. And hey, look at that. So as the OBD signal is decreasing, so is the 896 message ID in position 1. It's also decreasing. And what I figured so far is there's about an 82 shift. So take the number on the left, subtract 82 or thereabouts, and you end up with the number on the right. Of course, I can do all of that in Excel with a data log. But this just confirms that that sensor is directly connected to the value in the CAN bus messaging. And so, let's see here. This, of course, is the race capture app. I just have it stored on the computer. And if I go to Setup, and if I go to Scripting, okay. Oh, and let me make one change here real quick. So right now, it is only looking at the address 1416, but I will change it to look at 896. And so this is the log here. And so here's the address 896, that's the ID rather. And then each of these values are in each of the positions of the CAN bus message. And so that's how I'm monitoring all of that. If I do this and equals, and I write that, then what we'll show now is this is every CAN message that the factory CAN bus is sending out, and the race capture is just listening to it. So what I did is I just took all of this data and I logged it. I then looked at each of the CAN address or IDs, and I started to parse them out to understand in an Excel sheet so far. Those are all of the addresses, message IDs that I've seen from the race capture. And then I'm logging, or as I go, I'm looking at each of these positions. What do these values represent? So I already have RPM sorted out. I've got throttle pedal position. I've also got throttle, what I'm calling throttle position, but that's actually the butterfly angle, so the actual throttle body. So these two things, the pedal and the throttle body, don't always correlate. And it happens to be that accelerator pedal position is reported out on two different CAN IDs. And then I've got some few here like intake air temp. I'm still questioning that, but I just confirmed it, that I am looking at the right byte of data. And then I've made some other observations here, and as I go, I'll get all this sorted out. The purpose of this, though, is to allow the race capture and my Arduino to passively look at the Audi CAN bus data and access data that is already available, rather than leveraging the OBD2 PIDs, because the PIDs, you have to actively request those. And if the race capture is actively requesting, then that can throw a conflict with any scan tool that you hook up, like Rostec VCDS. And so you can't have two different tools that are connected at the same time requesting OBD PIDs. So if my race capture and or the Arduino are just passively looking at data that's already available, then it frees up the car to be accessed by any diagnostics tool or whatnot, just like it would from the factory. So the goal of this is, again, to direct map the CAN data and use that for e-booster calibration and other parameters that the race capture would data log and monitor, and allow the OBD system to be utilized like it was originally. So a little bit of a long video, but hopefully that steps through some of the things for you guys, and let me know if you guys have any questions. I'm still learning a lot of this. There's a lot more to learn.